Good morning. This is Ms. Billerbeck, and we're going to talk about solving equations with a variable on both sides. So let's say there's some friends, and we want to go to a couple theaters or one theater, but we have two theater options. Their price of tickets is a little different. One's more comfy with those, reclining chairs and all, and one has cheaper popcorn. So we kind of had to figure out when it would be okay to go to theater A or theater B. So we want to go the one where it is the best price for both, for all the friends. So let's have our variables relate to the word. So friends, and then P is going to equal popcorn. Okay, so friends are each will have a ticket, and P will have the popcorn. So we don't know how many friends are going to need tickets. Okay, so we are going to write some equations. So for our first theater A, we're going to write the cost is going to be the ticket price, $14.50, times the number of friends plus we have 575 times the number of popcorns we buy. Theater B cost is going to be $13 times the number of friends plus 675 times the number of popcorn we buy. Popcorn containers. Those extra larges are always such a deal, aren't they? All right. So, first of all, let's say we only buy one popcorn and we share them, and let's say we have one popcorn, so P equals 1, and two friends are going to do this. So that gives us F equals 2. So now we can plug that back into both of these equations to see what's going to be the best deal for us. So we have 1450 times 2, because we have two friends, plus 575 times 1, because they're only buying one popcorn, and we want to see what that equals. So 2 times that is $29 plus the 575, and that gives us $34.75. Okay, so if we're doing option B, going to theater B, we have $13 times 2 plus 675 times 1, and that's going to give us 26 plus 675, and that gives us 22.75. So theater B, this is B, this is A. So theater B is the winner. Okay, so that for two people and one popcorn, we want to go there. Okay, but let's say we had a few more friends. Okay, let's say we had poor friends, and we decided to do, well, if we do two popcorns, let's do 5 friends and 2 popcorns, because then that's not going to be proportional. So we're going to do 5 friends and 2 popcorns. Okay, so we are going to put 1450 times the 5 plus 575 times 2. Okay, so 1450 times 5 plus 575 75 times 2, and we get $84. That's a lot of money. Okay, then we do 13 times 5 plus 5, whoops, 675 times 2. Let me quickly do that one. So 13. Okay, so theater B is still cheaper even after all that. Okay, so I guess it's just going to matter if we buy a lot more popcorns than 2. Okay, so let's say we do a break even, but let's see the break even with popcorns. Okay, so let's say we have the 5 friends. Okay, so, and we don't know how much popcorn we can buy to break even. Or, yeah, let's do that. So we have 1450 times 5 plus, and we don't know how many popcorns we can buy until we have a break even. So we're going to leave that P. And then we have 13 times 5, and we have plus 675 times P. Okay, so we want to move everything over here. So 13 times 5, that, well, let's go ahead and calculate this. We'll move this over and calculate at the same time. Save line. Okay. So 1450 times 5. I'm just going to do that quickly. So 7250. And then we have equals, so this one's just going to be 65. And then that's plus, and this is just going to be P. So when we move this over 65 and move 65 here, we ran out of whiteboard space, but we could still find the answer. Let me put this over here. Okay, so we have 7250 minus 65. So 7250 minus 65. So that's going to give us 50, and then that's 0.750. So 7.5. So 7.5 equals P. Can we order half a popcorn? No. So we have to order 8 popcorns for 5 people to make theater A more attractive than theater B. Okay, so pretty much we're going to be spending time at theater B. All right, unless we really wanted to show off and go with the cushy seats and, you know, special occasion of some sort. So then we would go to theater A. Okay, so example 1. What we are going to do is do it, we're solving because there's an equation here, an equal sign. So what we're going to do is distribute. Now, I circled this before because I want you to be in practice, circle the negative sign so you don't forget to distribute it. Okay, that's the #1 distribution mistake, is to forget to distribute a negative to the second term. Okay, so we have minus, and then the 0.2 times 100 is just 20, equals, and then we have negative 50z minus 8. Okay, so we're going to move our 50 over here. And we're using an additive inverse, and we have 150z minus 20 equals negative 8. Now you can easily do this on the exact same line, okay, and put the plus 20 there. I'm just doing it slowly. So this gives me 150z, and this zeroes it out, so I end up with 12. Okay, at this point, I'm going to divide by 150 on both sides. Okay, so that gives me z equals, and I have 12 over 150. Now, both of those are divisible by 6. So 12 divided by 6 is 2. 150 divided by 6 is, believe it or not, 25. So there's 6 quarters in $1.50, remember? So that would be the answer. All right, on this one, we are going to distribute and distribute this. Okay, so we have 5/8 times 16d plus 5/8 times 24 equals 6d minus 6, and there's a plus 1. Okay, so we're going to simplify here. So I'm going to put an S there for simplify. We're going to need my other board back, so I'm going to erase this. Going to be a bit of work. Okay, so we're going to simplify. So when we divide this out, we see we have 1 here. This is 2. So this gives me 10d plus, there's 1/8 and 3/8 here, 15 equals 6d, and negative 6 plus 1 is minus 5. Minus 6d minus 6d so we have 4d plus 15 equals negative 5. All right, so we're going to use an additive inverse here, negative 15, negative 15. So 4d, oops, I should be writing additive inverse, additive inverse. So I have 14 equals negative 20. And then I'm going to use a multiplicative inverse. If I'm multiplying by 4, I'm going to divide by 4. And my final answer is going to be d equals negative 5. Okay. And we can quickly plug that into the other answer to check it as well. Okay. So, oh, and on this A, I probably should have written this as a decimal, shouldn't I? See how that's a decimal? So let's take a look at that. If I have Z and I wanted to write it as a decimal, remember how we do that really fast? So that's 8 over 100. Okay, so then Z equals 0.08. Okay, so that's how we would write it as a decimal. So either answer like that would be fine. Okay, and then you just plug it in here and plug it in there to check. Okay, I'm going to save you some time, so I'm not going to check it. All right, let's go to this one. All right, we have t minus 27 and an innocent little negative here is negative out here. So we have to actually remember that that's negative 1, and we're going to distribute it to both terms. So we have t minus 27 equals negative 27, and then that negative 1 times negative t is a plus t. So we're going to see we have a problem really fast. Let's actually, let's do it this way. Plus 27 plus 27. That zeroes out, and we have t equals t. That's always true. Okay? If we had subtracted t on both sides, we would have had negative 27 equals negative 20. It would 27. So negative 20 equals negative 27. So that would have been always true. Okay, so this means that we have infinite solutions. Okay, so when we get into looking at linear systems, what that looks like is we have a line on top of another line. So it's actually the same line when we look at linear systems. Okay, and those would be coincident lines if we were talking about what type of linear system are we looking at? We'd be looking at a coincident system. Okay, so then we have 16, and we're going to distribute that to both of these. 96, we're going to distribute that to both of these. So 16 times 4 gives us 64. Then we have minus 48m equals, and this one we're going to have negative, and that's going to be 48m, and then plus 96 when we finish distributing. Okay, so if we add 48m to both sides, we are going to have something strange. 64 equals, and then we have 96. Well, 64 does not equal 96. That is never true. Okay, so in this case, we have no solution. Okay, and what that looks like in a linear system is parallel lines. So when we get to that, we're going to see parallel lines that never intersect. Okay, so these intersect infinitely on the line. So you should probably say they intersect infinitely on the line, because they don't have an intersection out here and here. If we have a line on top of a line, these never intersect. Parallel lines, they never intersect. So there you have it. Okay, so let's go on to coffee. Okay, I have to have my coffee in the morning. It's very important to me. Okay, so how many pounds of Arabica coffee should you mix with 5 pounds of Robusta coffee to make a coffee blend that costs $12 a pound? Price per pound right here. Blend, $12 a pound. Let's put it there. So we have $12 a pound. So we're making a chart. So dollars per pound times pound is dollars. Okay. So now we know we had 5 pounds of Robusta. So we're going to write 5 pounds right here. Okay. So we don't know how much Arabica we're going to put in there. So we're going to put X for Arabica coffee. Okay, so if we want to know how much total poundage we have for the blend, we're going to write X plus 5. And that gives us the total amount of coffee for the blend. So remember, dollars per pound times pound is total dollars. So this is going to give us 28X. And then this, we're just going to multiply 875 times your 5 pounds and get 43.75. Okay, this one we have 12, and we're going to multiply x plus 5 there. And now if we add up the costs, we have 28x plus $43.75 should equal 12 times x plus 5. And then that's going to help us answer the question, how many pounds of Arabica coffee should we mix with 5 pounds of Robusta coffee to make the coffee blend that costs $12 a pound? Okay, so we take this 28, and then we add 43.75. And then that's going to equal, let's distribute this here, so 12x, and then 12 times 5 is 60. Okay, so we're going to subtract 12x here. And that gives me 16x plus 43.75 equals 60. And then I'm going to subtract 43.75 from 60. All right, so now I need another board again, so I'm going to erase my workboard really fast. Okay, so that gives me 16x equals, and then this one's going, we have to take this is a 5, we have a 9, 9, 1. So we have 5 to 16. Okay, so it's going to be around 1. So we take 16, x divide by 16, and we get, voila, the poundage. Okay, I don't want you to miss out. So let's see how many pounds. So because I am tired and it's getting late, even though I'm teaching this to you in the morning, I'm using my calculator. So this is going to be 1.01, but it's 1.5, so we're going to round that to 1.2 pounds. So we just figured out that this is how much Arabica coffee. So we're going to use 1.02 pounds of Arabica coffee to mix with 5 pounds of Robusta coffee to make, that's going to be 6.02 pounds of the blend for $12 a pound. So that's how many pounds of Arabica coffee. So 1.02 pounds. So there you have it. Example 3. Okay, example 4 is pretty easy. So let's look. Okay, so Cameron's friend tells him another service that has a joining fee of $15, but it's only 80 cents a song. So it's a cheaper song per dollar than Cameron's current plan, which is 95 cents a song. So we need to know at what number of songs does this new service become less than the old service. Okay, so we're going to take this new service, which is 80 cents a song, and I am going to define my variable s equals song, so I do not forget what my variable means. And then, oh, but I had to add $15 for the joining fee, so there you go. So this varies depending on how many songs I buy, but that one-time joining fee stays one time. So now I have 95 cents times the song. So I move this over to the other side. And this is 15 equals, and then this is going to be 15s. Okay, but we don't need to write the dollars because This is dollars per song, and that's song. Okay, so let's see how many. These are both dollars, by the way. So, well, I guess we can write dollars. Okay, so it's going to cancel in a second. So we have 0.15. Okay, so when we divide 15 by 0.15, we get 100 songs. Okay, so at 100 songs, they both are equal. So as soon as we buy 101 songs, the new service is a better deal. Okay, so it depends on how many songs you buy. If you don't buy more than 100 songs, you should stay with the 95 cent songs. Okay, but if you're a big song buyer, then go with the 80 cents per song with a $15 joining fee. All right, that's it for this lesson, and I hope you have a wonderful day. Bye-bye.